Hello, everyone. Welcome to this session. Hi, Ritvik. I don't think it's going live in the YouTube.
It will be going. There will be 30 seconds delay. It will be going on. It's live. You can continue.
Hi, everyone. Sorry for the initial technical glitch, but welcome to this session finally. So we are here today to discuss on a prototype and an idea that we have been working on to empower machine learning in the field of enterprise asset management. Let us first introduce ourselves here. So I'm here, Soumalya Nath. I'm initially from Kolkata, India, and currently I live in the Netherlands and work for Accenture. My hobbies are biking. Of course, in Holland, you cannot go anywhere without a bike. And call me old fashioned, but I just love to sit on a park bench and think. Doesn't really matter what I'm thinking of, but I just like to do that. I'm here with Mustafa.
Hello everyone, my name is Mustafa Demiray. I'm originally from Istanbul, Turkey. I am currently living in the Netherlands. As you can see in my picture, same as my colleague, I am also a bench thinker. Rest of my free time, I love traveling and cycling. Other than that, I'm very happy to take a part of such an event like this.
Hello everyone, I'm Lisa and different from my fellow colleagues, I'm a Dutch from origin, and as much as I love living in my home country, I love to escape its busyness for a while by chilling in the sun when possible and exploring the rest of the world. Well, I hope this gives a glimpse of who I am to you guys.
Thanks a lot, Lisa. So other than us three, there are other team members who have helped us work in this prototype. You see their names in the slides. Unfortunately, they could not join this session with us, but we definitely extend our gratitude towards their hard effort and work. So what are we here to discuss? To start off, let's take a glimpse into the life of a supervisor. We have a friend, Josh, who happens to be a maintenance supervisor. Let's take a glimpse into one day in his life. Curtains.
Hi, I'm Joshua. I work as an equipment and maintenance manager at an electrical engineering company. I manage all equipment in our company, and I'm also responsible for the maintenance of our assets. So, one of the challenges of my job is to keep track of all the equipment we have and to make sure that they are maintained on a regular basis. And then especially the part where I have to do the administration.
So now, in this kind of situation, for a maintenance supervisor, for his administration jobs, the most important one is to assign proper maintenance plan to each equipment in a system for the organization, right? Now, generally, for this type of work, we can categorize three type of people. First, the super duper experts. These guys are the people who have made their hair gray in SAP. Yeah? They really love the SAP GUI transactions, the old heavy loaded stuff. No matter how complex their UI is, but they just love to enter that data and to work. And but here as well, after entering a new equipment, they need to search for the proper maintenance plan templates from the system. And since these guys are really experienced and have a lot of knowledge, they manually assign the maintenance plan to our equipment. Now, just think of the second mode, who are the normal users. They like to work with Fury applications. Yeah. But here again, they need to enter equipment details, etc. And then they need to search for proper maintenance task lists. And then they need to map these two together. For both of these modes, the common factor is that it's highly dependent on the knowledge and experience of the supervisor. Because yeah, he makes the final decision. He make this entire thing is a manual process, you know. So that's why this is where we came up with the third mode, which we call the IMPS. Yes, as you can guess, this is the prototype that we have been talking about so long, the Intelligent Maintenance and Planning System. So what does IMPS actually facilitate in the life of Josh? Josh, what do you think IMPS does for you?
Let me show it. Aha, look, I just got a message that we bought a new equipment. I can click on it and see what it is about. A new transformer. Cool. Aha, so this is how the transformer looks like. Let's input it in the system with that new app. So yeah, this is the new app I mentioned. So with this intelligent maintenance planning system, I can create assets and also have an overview of the equipment we already have. But first, let's create a brand new equipment in the system. We can use the QR code scanner to get all the required information of the transformer, put it in the system without manual input, even add additional information in the attachment, have a final check if everything is correct, and then save it. Okay, so I see that the equipment has been successfully added to the system and is now number 18401. Good. So now I can go back to the equipment overview, and here I see all the equipments that belong to our company. So I see the new equipment over here. Yes, that's the same number, 18401. However, it still has an unassigned maintenance plan to it. That's right, so we still have to add that. Yeah, this really used to be a time-consuming task. I had to go to my desktop PC, look for all the maintenance plans we had in our company, find the right one for this new equipment, and then assign it all manually. Good that that is automated now. I just click on the equipment and get a list of the most suited maintenance plans for this new equipment. So this app is able to go through all the maintenance plans we already have on the system, predicts which maintenance plan is most suited for the new equipment based on its details, and provides the best scoring maintenance plans in the list over here. And the score on the right indicates how much this maintenance plan suits the new equipment. And to be sure that the best suggested maintenance plan is actually relevant for this equipment, you can check the tasks that need to be performed over here. For example, I know that for this kind of equipment, you really have to check for corrosion, and I see that's there. Okay, that seems good for me. So I will assign this maintenance plan to our new equipment. Great. So I can now go back to the equipment overview and make sure that the inspection plan is really added to it. Let me find the new equipment. Great. I now see that the status is green and that the maintenance plan is assigned to it. So yeah, as you can see, this app really makes my work a lot easier.
So thanks, Josh. Now, while Josh enjoys his beer, let us get on with our presentation. I'll show you how IMPS actually works now. It's a very, very simple architecture. So we have a machine learning block. We have a machine learning block where we are using a logistic regression ML algorithm. That we have a trained model which is trained on historical equipment data in the system. So all the available equipments along with their features in this organization are fed to this model, along with the maintenance task lists that have already been assigned to similar equipment. So the model actually reads these data, and then when a new equipment feature is fed to the IMPS system, it makes or picks up the 3 most valuable maintenance plan, which according to its model is the best fit for this new equipment based on its features. Now, as this is what you have seen in the application demo, and if the supervisor agrees with the machine learning recommendations, then he just clicks assigns it, and then the rest of the workflow just follows on. So this is how it works in the technical architecture. Now on the infrastructure side, we initially did everything in the SAP Cloud Platform. Okay, so we had Python WebSocket where we deployed our machine learning algorithm in the Cloud Foundry. And that was integrated into a SAP UI5 application, and it consumed data from a HANA database. Now, we thought to add a little sass to it. So we took it out, our Python code, we took it out of the Cloud Foundry, and then we put it in the AWS cloud, where we deployed it as a Lambda, which as you know is like a functional service, and exposed it with the API gateway. So this opened up a wide range of gates for us. Now this particular algorithm model can actually be used with multiple applications, be it SAP, be it non-SAP, anywhere. It's just plug and play now. How did we do it? I'll just show you. So in the AWS Cloud9, we created an environment for our code where we deployed it. We call it the Power Classifier code. And from AWS Cloud9, we deployed the Lambda service, and we created an API gateway trigger for it. So this just published it in public cloud with a simple URL, which we can hit from any web-based application or the browser. And our machine learning algorithm returns the output in a JSON format, which can easily be integrated into any UI5 or any front-end application. This is how we did it. So now I would ask Lisa to actually give you a little bit more info under the hood.
Yes, so let's do a deep dive into this geeky logistic regression for a while. Logistic regression is a learning algorithm. Yes, a learning algorithm, as this algorithm is actually learning from experience, as it uses historical data as a basis. This algorithm can be used in several problems in multi-class classification, indicating that data can be classified into more than 2 classes, which you can see on the left image, in which the different types of figures show the different classes available. The underlying logistic regression algorithm provides an intelligent mapping of equipments to multiple maintenance plans IDs. It checks by estimating the probabilities to what a maintenance plan a new equipment most likely belongs. Besides, logistic regression makes it possible to check the probability score of new equipment to all existing maintenance plans available. And this makes it possible to rank the 3 maintenance plans the new equipment most likely belongs to. The logistic regression algorithm is applicable for our IMPS case, as with this, it is possible to predict models that are based on different data types for features. And this is the case in our solution, and it predicts relatively fast for moderate-sized data sets. So next, we are moving towards the mandatory building blocks for our logistic regression algorithm. These are the pre-processing of our data, splitting our data in order to train the algorithm, and fitting the model, and afterwards evaluating its fits. For this case, the first step is pre-processing the data, and this includes encoding categorical values into numerical ones of 0s and 1s, as the algorithm is only capable of handling numerical values. Moreover, it includes standardizing numerical features, and this includes equalizing the variances in variables. This ensures that all variables are contributed equally. Well, the next step is dividing your dataset into a train and test set. The training set contains of a known output, and the model learns from this data in order to be generalized to other data later on. We have the test dataset in order to test our model's prediction on this subset. Now, well, afterwards, we're going to fit the model by applying the algorithm to the trained data. After this data is done, after the fitting is done, you need to evaluate how well the logistic regression model classifies unseen data to our classes. In order to evaluate this, we use evaluation metric accuracy, and this measures how close a value is to its true value. This is one of the most important ones for our case, as an accuracy score describes the difference between the measured values by the algorithm and their actual values. As of course, the goal is to obtain the highest possible fit with this machine learning algorithm, but then your guy's thinking probably, okay, what's this meme saying? Not sure if good fit or just overfitting? Well, I'll just explain to you shortly, because overfitting is likely due to fitting your model too well on the available data, and this really needs to be avoided. By splitting the data in train and test and evaluating your fit, you overcome this problem. Well, for now, I'm giving the word to Mustafa as he is explaining to you guys what code is behind this method.
Thank you, Lisa. Of course, we are starting our code inspection session with a good old Linus line. It's because it's essential. We are using scikit-learn open source library for our solution. And we are already familiar, as we are already familiar with these building blocks, we are going to inspect our code in same 3 steps respectively. So first step is preprocessing the data. For applying a machine learning algorithm, using a well-structured data set is the most important stage for the quality of the training. Since we have a lot of categorical data in our dataset, we need to use one-hot encoder module from the scikit-learn library. This module encodes categorical data to binary metrics that regression algorithm can get trained from it. First, we are creating our instance with only handle unknown parameter, which used for if unknown categorical feature is present during transform. Default of this parameter is error, but since we know our data set very well and we changed it with ignore. And after this line, we have our column encoded. So we are basically modifying our data frame with the new data. Meanwhile, encoding categorical data, we are also standardize our integer variables as well. This perform is helpful. This action helpful for the training of the algorithm. We are using scale functionality from the library itself for performing this. After performing both encoding and standardizing steps, now our dataset is ready for the next step, which is splitting and setting a dataset. Let's go into it. We already mentioned about how important dataset quality is, so we need to split our dataset wisely in order to use efficiently for training and testing the model. As can be seen, we are splitting 30% of our dataset for testing, so we are training our model with the 70% of our data. After performing this step, we are ready for the last one, which is fitting and validating the model. After we prepared our data and split it for training and testing, we are ready to apply the real machine learning part. So we are creating our logistic regression model. So this model has also has built-in solvers that helps the optimizations of the problem. Since our case is a multi-class problem, we are using LBFGS as a solver. Since we already have all the necessary data in the various variables, because we performed our previous step, we are training the model with the giving data with the fit module. After training the module, we are using our test variables to making a prediction. Then finally, we are preparing our output to have best 3 outcomes from our model. So these were the code snippets to show our flow in our solution. Let's see a glimpse of testing the algorithm, the training, so we can see how it works. We can also verify the training of the algorithm with simply giving different inputs to our model. We prepared 2 cases with the low and high confidence rates. One of these example has similar features of the equipments from our dataset, and the other one has different random features just to show our model's reaction. When we gave these inputs to our model, as we can see with the good case, model is predicting with a pretty high confidence rate with the 88%. But since our model didn't get trained from the other random features, it is predicting with a very low confidence rate, such as 45%. Since this is a now software as a service product, it can be integrated with any UI, with any DB. And the solution is also can be packaged as a subscription model. So that's also saves a lot of headache and with contracts and licenses. Even though we are only using our classifier for determining the maintenance plans, it can be used for other domains as well, as long as if we have a proper data set. And last but not least, if this solution will be used for multiple applications, then maintenance cost can be significantly reduced. That's it for now, our solution. Thank you everyone for joining us today. Please feel free to contact with us in case of any questions. Have a wonderful day or night.
That's a really great presentation, Mustafa, and all. So as of now, I don't see any questions. So let us see for 30 seconds, because we are having 30 seconds delay. So let us see.
Yeah, sure.
Yeah, I don't see any questions. So let me share my screen as we are running the raffle. So let me share my screen and run the contest.
Yeah, sure.
Okay. Okay, so I'm running the contest. So the winner is Sachin Nagel. So I will reach out to Sachin Nagel in Discord and I will share you the details. So let me once again cross check if there are any questions or anything. Yeah, so no questions. So we can close up the session. Thank you guys. Thank you very much.
Yes,
Sure.
thank
Thank
you. Bye-bye.